can reach is only like 900 degrees Celsius.
Sure.
So if that is over 900, I think 99% of customers they will use the thermocouple. Otherwise, they will break the resistor. So for the thermocouple, we have two wires, right, with different materials,
Yes.
two different types of metal. So if you have a really high temperature in that, you have the thermocouple wire to be pretty soft and change its shape. So if you use a drywall, drywall has the probe in the vertical direction. So if you have the thermocouple like that way, if the temperature is pretty high, then you will drag the thermocouple wire because of the gravity.
Sure.
So in that way, the sectional, the cross area of the thermocouple wire will become smaller. That means the thermocouple structure that will be different. Then you may have like a few milli-K error or difference than before.
Right.
Stuff like that. Yeah. So for the thermocouple calibration, especially for temperature over 1,000, like horizontal furnace, that would be better. But that's not a absolute correct answer for everyone because just like I said, for a few milli-K difference, it is okay, or it can be ignored by the industrial customer because their like accuracy requirement just like 1,000 milli-K or 500 milli-K, something like that. So they don't care just a few milli-K. So for the industrial customers, the drywall that we good enough for them. But for the labs, especially for the like national lab or pretty high level third party lab, if they do need to test a lot of like a thermocouple, noble metal thermocouple like type S, B, and R, a few milli-K difference, that would be a pretty huge problem for them. So so this is why we have the drywall, but we still have the horizontal furnace. So this is the reason why we need that. So anyway, so for the 850, we have already introduced this far. So for the specifications, that will be you can easily find on datasheet. I think they may trying to, they may trying to find the Atel drywall. Sorry, Atel 850 is better than Fluke because most of our customers they are using Fluke. So for the specifications, we have a better uniformity, better heating and cooling time than the Fluke 9118. So we have more information later. So for the thermocouples, we have two categories, as you know, base metal, EJK or something. That would be pretty cheap. Just maybe just US dollars for that. We have noble metals, B, S, and R. That would be high frequency, something like that.
I know R and S. I don't know B.
Oh, really?
What is B?
B is the some of the customers may in some of country they consider B as base metal, but some in the United States or China or some part of Europe they will think B is for the as the noble metal. I don't remember the material,
right?
But it must be something with the platinum. Because I just don't know that I don't know I don't remember the materials.
No, that's fine.
I know so far, not a lot of people they use type B.
No, okay.
Yeah, most of the customers they prefer S and R because they are more common. If you look at the thermocouple composition cable, we just removed the 9080. That is the thermocouple composition kit, composition cable kit. We just removed the B type composition cable because after a lot of research, we found only a few customers they need a thermocouple type B.
Yes.
Okay, so it is definitely not common to see in the market. Okay. Yeah, for the material that would be. Let me check if I can get the result quickly. maybe you'll have to Google it later.
Okay, that's fine. No problem.
Yeah. So the precautions when using the base metal and noble metal. For the base metal thermocouples, most of the customers they have the like armored base metal thermocouple, like the we have like a metal shell on the outside, something like that, and that is because this is quite widely used in the industrial field. So they need something can protect the thermocouple well. So they have some like pretty cheap metal used to cover the entire thermocouple, something like that. So for the base metal thermocouple, especially with the shell, we don't need to worry about the contamination, something like that. But for noble metal, S and R, I would say 80% of the noble metal probes we have, they are exposed thermocouples, like the picture. Yeah, like the picture below, like this one. Yeah. So the problem for this one is you can see the thermocouple tip is actually exposed to the environment.
Yes.
So if you're testing some like like mixture of the noble metal or base metal, or use the noble metal as a reference to test the base metal, because of the base metal thermocouples may have some contaminations outside of the probe, then if you have a really high temperature testing, you can easily imagine that the contamination will get from the noble metal probe to the tip of the thermocouple, because the tip of the thermocouple is explosive. And then the noble metal thermocouple will have a pretty huge error. That means you cannot use it anymore. You have to cut the line and redo the welding, something like that. That would be a pretty huge problem. That would be a lot of work, something like that. So for the exposed thermocouple, actually, no matter it is a noble metal or base metal, you better have a sheet outside. This sheet can be what is called a ceramic, or what we have is the aluminum, something like that.
Yep.
So those are non-metal stuff, so we don't need to worry about the contamination or something like that. Yeah, so this is the thermocouple thing. So when testing about the base metal, so oops, sorry. So as you can see in the picture, so this is a Fluke 911A. So normally when we test the base metal, because we do have a sheath on outside of the thermocouple probe. So when we do the base metal, because it's pretty cheap, we don't need to worry about damage it. So normally we just make a bundle of it. In the middle point, that would be the reference probe. Okay, so you can see we have a bundle like this, but in the middle point, we have, like this.
Yes.
We have thermocouple in the middle.
Sure.
Okay. So as you can see the picture right here, the probes are the noble metal probes. This is definitely an armored probe like this. And in the middle one, it's white color because this is not the thermocouple itself. This is the thermocouple inside of the aluminum sheet. So that means we have exposed the thermocouple inside of the white color aluminum sheet like this.
Yep.
Okay. Yeah. So when we test about base metal, we normally will make a bundle like this. But this traditional way gives you a problem, that is you can see the diameter of this bundle is definitely smaller than the hole, right? So it will bring you a problem that you will see the bundle drop on the bottom of the core like this. So that means the center point of the bundle is not on the center point of the probe. Of the core.
Yep.
And this will give you a little bit temperature difference because we have the uniformity, something like that.
Yep.
This may give you a result like on the top of the bundle may have a temperature difference, maybe like a 0.3, then the bottom one, or something like that. So So this is the traditional way. So to conquer this problem, we have a special cup design, or we can say the multi-hole design. That's the insert. So you can see the multi-hole design like this. This is a pretty good for some customers if they only need to test only just a few thermocouples at one time.
Mm-hmm.
So they put the reference probe in the middle, and for the other DUT test, they can put on the other holes like this, okay, and then put this insert together into the core of the furnace. So we can make sure that in the middle point of the insert, it's definitely the middle point of the core. So that means we have a fast temperature point right here, and also because the insert is the metal stuff, so we have a pretty good temperature like transferring efficiency. So that means we can make sure the temperature difference between each hole is pretty small, something like that. And also the good thing for this one is the customer, they don't need to use time to make the bundle. They can just simply insert it into it. With the traditional way, no matter how many probes they need to test, maybe just two DUTs with one reference probe, they still have need to make the bundle. But this time, they don't need to do that. So this is a really good solution for the customers if they only need to test a few thermocouples.
Yes. Now, can I ask a question?
Yeah, sure.
The actual evenness through the hole, do you need to have a thermocouple that fills that hole, or can you does it need to be the same diameter, the thermocouple, as the holes?
Not really. You just need to make sure the diameter of the probe is smaller than the diameter of the hole.
Yes, of course. Yeah.
Because the entire temperature zone of the furnace is definitely pretty sealed. So we have a ceiling on this side, on the other side. Yes. So the entire field has a pretty, stable temperature, and the entire field has almost the same temperature.
The radial accuracy is how it fits in here, and the actual is how deep it goes. Yeah.
Yes. So it's like the length is about like a 300 millimeter or something like that, or even 200 millimeter. So that is pretty far away from the tip from here. So that means that we don't have a lot of heating leakaging right here. So that means we may have like 80% of the entire zone have the same temperature. So that means we don't need to worry about that.
Okay.
We don't need to if the probe has a pretty huge gap between the probe and the insert hole. This is pretty different than the drywall insert, because the drywall insert, if you look at the insert, the top of the insert is actually exposed to the environment. So you will have a pretty huge temperature leakage. But this time, let me see the picture right here. So yeah, as you can see, you will insert the entire probe right here. And this is a probe. The actual length of the, let me see. Yeah, as you can see right here. So the hole is right here. So the entire length of this part is not that big. So maybe when we do the testing, the end side of the furnace is right here. Okay. So the tip right here to the open side of the furnace is maybe like over 200 millimeter. So the gap between the hole and the probe is definitely no problem at all, because the gap will be filled by the hot air, and also the hot air is pretty far away from the heating leaking point, so we don't need to worry about. So for example, we may have like a 1000 degrees Celsius right here. So here's the end of the furnace. We may have a 990 right here, 990 right here.
Right.
But starting here, that'll be 1000 again.
Sure.
Means we have enough length with the high temperature or the stable temperature right here. So we don't need to worry about the gap between the probe and hole. So, well, this is a really good question. Yeah. And also this is the reason why the furnace, horizontal furnace is better, because we don't need to worry about the hole size. Yeah. Okay.
Sure.
Anyway. Yeah.
And the cup is just going to take a bundle like we had before.
Yeah, so that's the second type one, second type right here. So we have another one. This called a cap design insert. So that would be a pretty big hole right here. So you can make a bundle like the traditional way. So this is good for the customer if they need to test a lot of TCs at one time, something like that. But for the multi-hole design, if the customer want to put two probes in one hole, that's no problem. They still can do that if they have a pretty thin probes like that. No problem.
Okay.
But for the design, yeah, let's go back to the cap design. So what you need to do is still the same thing, make a bundle like this. They may need to use a metal wire like this. I don't remember a nickel as a material, something like that. I don't remember. That's a standard accessory. We'll give you like a pan of the wire, so the customer can use that to make the bundle. Yeah. So if they want to use a cap design, they need to make a bundle like this one, and they need to make sure that the reference thermocouple has a little bit like older than the DUT probe, because we have a hole in the middle right here. Okay, so the tip of the bundle will be placed in the middle right here. Okay, so because only in this way we can make sure the center point of the bundle is in the center point of the core. That will give you a better thing. Okay, so that means the entire bundle is definitely hanging inside of the furnace because of this point right here. This side is the side of this side of the bundle is supported by the hole right here, and the other side is supported by the frame like this.
Yes, I understand.
Of course, yeah. So we can make sure that the center point is definitely on the same line of the center of the furnace. Okay, so this is for the base metal. We have a two design of the insert, multi-hole design or the cap design. Some customers they may ask, do we really need the insert? The answer is no. They can use the bare hole. They can use they can use the furnace without the insert.
Yes.
For example, a pretty big bundle, and the cap design doesn't have enough diameter for that. So no problem. They can put the entire bundle inside of the furnace. No problem. But just like the traditional way, they may have a problem that the entire bundle is at the bottom of the furnace core, something like that. So, but anyway, if they have a really high accuracy requirement, then no problem for that. I think most of the industrial customers, they're okay with that. About noble metal, so the traditional way we have is like something like this. Okay, so as you can see here, they do have a white color sheath right here.
Yes.
So this is not a thermocouple. This is a sheath. So the thermocouple is inside of it. So the traditional way is doing something like this. Okay. So you have only one side support right here. So that means you may have two probes that is inside of furnace. But the problem is, let me see. Yeah, although the picture shows you that the probe is still in the middle point of the furnace, but the actual thing for the traditional way is the probe may be like placed like this. Okay, because you only have one support right here. The other side you have to reach the bottom of the core, something like that. Yeah. So this is actually this is okay. This is definitely okay with that. But the problem is the temperature right here is not in the middle, or it's pretty far from the middle. Yeah. We may have a temperature difference from center to the bottom. Maybe we have 0.3 degrees Celsius, and this is okay for the industrial customers, but for the lab users, that's a pretty huge temperature stuff. We may have a pretty big temperature difference between two probes because they're not touched with each other. So there's no high temperature transferring efficiency between them. So they may have a little bit of temperature difference, maybe just like 0.1 degrees Celsius. But this is not acceptable for the lab user customer.
Yes.
So our solution is like, we have this one. This is what we call the alumina tube kit for the noble metal stuff. The thing is, we have a support like this. Okay, so you need this support on the both sides of the furnace. Okay, and in the middle part, that will be a pretty long tube like this. This is an alumina tube, so we don't need to worry about the contamination. This is not a metal one.
Yes.
And the small things right here, that will be the sealing point to reduce the temperature leaking, stuff like that. So you would have the bigger support like this to hold the two sides of the tube like this. So in this way, the tube will be hanging in the middle of the furnace. So this will give you a situation that the entire temperature zone is smaller than just the temperature core.
Sure. Yeah, I understand.
Yeah. So when we do the like noble metal testing, we put the probes. Okay. We put the probes through this little hole right here.
Yep.
Okay. So the first thing is the diameter of the tube is pretty small. So that means we don't have a lot of distance between the furnace core and the bottom of the tube because we reduce the diameter, right? So the other thing is when we place like this, okay, normally the two probes they'll touch each other. So that means we have a higher temperature transferring efficiency than the traditional way. So that means so we can say there's no temperature difference between the DUT and the reference.
Yep.
Because they're each other, something like that. So so this is the alumina tube kit. So when we do the testing, so normally we would just for the noble metal testing, we would only test one DUT at one time. So one reference and one DUT, something like that. So we have two holes right here, or we can say one hole for two probes. This is good enough. If they have three probes, no problem. They just need to put the put this little thing upside down. Then we have a right here, probe 2 and probe 3, something like that. They will stay together, something like that. Okay? So this is the solution for the alumina tube. If a customer want to use the bare hole directly, we do not recommend that because if they use the same if they use the same way to test the noble metal, they may have a little bit of contamination inside of the what is called inside of the furnace core, because the base metal, stuff like that. So if they directly put the thermocouple, noble metal thermocouple inside of the furnace core, they may have a contamination with the high temperature. Okay. Yeah, so this is the noble metal insert solution for that. So so the accessories for that. So right now you know how to use the A50 to test both of the noble metal and base metal, right?
Yes.
So we have two solutions. Base metal, we have the insert, or they can use the furnace without the insert, no problem. For the noble metal, we use the alumina kit, like this, something like that. So this is how we use it. So the great thing for the A50 comparing with the Fluke one The first thing is we have the color touch screen, and we can change the angle of the display. So some customers, they may place the furnace, in this direction or the other direction. No problem. They can move this. They can move the screen. So no matter you want to use it, no problem. The second one is we do have the Atel Link. That is a remote monitor stuff, and also temperature control. So they can monitor the temperature on their phone. So they can change the temperature when they have lunch, something like that. Because
sure.
For the furnace, we may need 3 hours to cool down from the 1200 degrees Celsius to the room temperature. That will take a really long time comparing with the dry well, because the dry well has smaller temperature field, but this one has a pretty big temperature field. So this is why we need a pretty long time for that. One point that A50 is better than the Fluke one is the cooling time. For the 911A, I think that's for the Fluke stuff. They may need 3 hours, 180 minutes to cool down from the 1200 degrees Celsius to room temperature. But A50, I remember it's just 90 minutes. So that'll be just a half time they need to wait.
Okay.
Yeah, pretty big advantage. And also with the A50, we have the probe holder. So this way, they don't need to bring another another support to hold the stuff. They don't need to adjust the height or something. And we can easily use this one to put the probe, push the probe from the outside to the inside. So this is pretty easy to use. So the accessories it being concluded. The first one, that will be the 3 different lens thermocouples. This is the control sensors. This is not a reference sensor. The control sensors, we do have the accuracy spec with that. That's 5 degrees Celsius. 5 degrees Celsius. So if the customer really want to use a display number as a reference, no problem. But the problem is it is not accurate enough. Although we do the temperature testing, we control the accuracy of the thermocouple only 1 degree Celsius. But when you combine 3 together, and after the algorithm, after the combination of the reading, the temperature accuracy is lower than the single thermocouple, something like that. And also after the transportation or long time using, the accuracy of the display number, that'll be 5 degrees Celsius. So that's pretty huge. Normally, you should not use that as a reference number, something like that. 3 thermocouple with different lengths, because the smaller one, because this is because the thermocouple is the furnace is pretty long, so we have divided the heating zone as 3 zones.
Yes, I saw that on something else.
Yeah, left side, middle, and right side. So the 3 probes definitely for 3 zones. And after that, we do have the algorithm to optimize the heating and cooling, and also the entire temperature field, something like that. So this is the thermocouple. If the customer has if they want to use their own probe as a control probe, no problem. They can use the type S or something like that as the control probe, no problem. Because
so the control probes are supplied with the instrument.
Yes.
Yeah.
Actually, 3 thermocouples, control thermocouples, are connected outside of the furnace. So it is not connected inside of it. So they can just use it if they want to use their own control probes. They can just remove the probe and insert their own one, and connect with the furnace. The connection is on the outside of the furnace, so they don't need to open the furnace. So the alumina tube, we have 8 millimeter as the outer diameter. We have 4 pieces. This is for the 3 control PCs. Okay. Yeah, we give you a spare one because the 850 is a pretty huge one, and all the accessories that we put inside of a long box, and also considering that the aluminum is not a pretty like strong material, so yeah, the carrier may break one during the transportation. We give you one spare one. Anyway, yeah, the nickel wire, yeah, the material is nickel. So this is to for the normal metal to make to make the bundle for the testing. We give you one roll for that. So we have another kit of the aluminum tube. This is for the reference probe. Yeah, as I said, the most of the normal metal thermocouple they don't have the sheath. They will just come with the exposed wire or something like that. So this is the sheath to protect them. So we have a 700 millimeter. That's longer than the furnace lens. The furnace lens is just like a 680 or something. So with this tube, we can see that one side is on the left side of the furnace. The other side, we can definitely put outside to the right side of the furnace. So this can make sure that the reference probe is hanging in the middle of the furnace. So this tube, the customer may use this at the first time they receive the furnace, because after the transportation, because we have a lot of vibration and shock during the transportation, so we do recommend the customers to give a temperature field testing once they receive the furnace, to test the entire performance of it. Yeah, and something is like, the interesting is the specification is definitely the bottom line. Most of our customers, they receive the 850, they do their own testing. They will find that the specification, like the axial uniformity, stability, or radial uniformity, is much better than the specification on the data strip.
Sure.
This is pretty common. So for some lab users, they need to give the customer like a list about their ability, about the testing accuracy of their lab or something. So when they do their own test about furnace axial uniformity or stability, they can improve the list number, something like that. So that means, for example, they can use the datasheet specification to calculate their lab ability. But after testing, they find that the 850 has better performance, something like that. So they can improve their service sheet about the accuracy or something about their service, something like that. So we do recommend the customer to test the uniformity and the stability once they receive the the furnace. Okay, so these two tubes, pretty long, 700 millimeters, are for the reference probe. Okay.
Yes.
Yeah. So the insulator, like this one. So this is the sealing to put it on the inside of the furnace to reduce the heat leaking. Why it's designed like this? Okay, this is a little bit strange. This is because we can use this one to test the radial uniformity. So one is always in the middle, and the other one is on the side. So for the bottom,
sure,
you're right here, or you can rotate the entire entire insulator. So they can, through this way, so they can move the bottom hole to the top.
Yeah.
This is to test the radial uniformity, something like that. And for the base metal, testing, as you can see from the picture, we have the insert cap design or multiple in design, whatever. This side we use this insulator to seal the. So we still have a two small hole right here. Normally it doesn't matter, but if the customer really care about that, they can use the what is called the fiber to seal the point, to seal the two holes.
Mm-hmm.
Ceramic fiber, something like that. That's for the high temperature. So this is one side of furnace. The other side, same thing. We need to use the ceramic fiber to seal this point. So in this way, we have no heating leakaging from the both side of the furnace. Yeah. Well, so the other thing that would be yeah, another kit of the Lumina 2. That would be 400 millimeter. So for the real testing with the reference probe, they may need this one to protect the noble metal thermocouple something.
Yep.
So this is only millimeter. Yeah. So the insert we have two types for each kind of the insert. Long one and short one. So long and short means the thermocouple length.
Yes.
Okay. So they may have a pretty long and pretty short. No matter what kind of they use, we do have the solution for that. The only difference between the long and short is just the support. What is called the support. The frame, the length of the support frame.
Sure.
It's just the end and also the top of it. That'll be the same.
Yes.
Exactly. Yeah. Yeah. So we have a so this is the insert. Yeah. So for the base metal, just ceramic fiber. It's right here. So as you can see, this is the bundle solution. Right.
This is what solution?
The bundle solution. You make a bundle for the DUT and reference. Yeah, something like that. So this is this is when we do the testing in our lab to test some base metal thermocouple.
Okay.
This is the insert for the normal metal. So how should we help the customers to choose the solution? So the first question we may ask is like, what kind of DUT they want to test, base metal or normal metal? So this is very important because we need to give them a solution like what kind of insert they need. The second one is the length or the DUT. If the length of the DUT is between 200 and 300, they need to choose the short solution.
Yes.
Okay. If the DUT length is longer than 310, then the long solution. They may have a pretty long DUT, maybe have 1 meter long, a probe like that. It doesn't matter. Because normally a thermocouple only need to drop the tip into the temperature. So we don't need to. If the DUT is pretty long, it doesn't matter.
Sure.
Okay. The last one will be for the base metal DUTs, like how many sensors they want to test at one time, just a few or a lot. So we will go with the multiple design or the cup design.
Yes.
So this is a table I made to help make the solution. Like question number 1, DUT type. For example, they they like base metal. Okay. Like a thermocouple type like this. They have a long one, and they have they need to test a lot of sensors at one time. So this is the insert model. Okay. So the complete solution, including the insert and the 850 drywall, that would be like this. So this is the order number you need to place
on. I saw that on the price list. Yep.
Yeah, right. That's right. So if they need a multi-hole design, so this is the insert model number. So they need 850 1200/no. That means no sensor, no insert, and then you need to order the spare insert for that, something like that. So this is the table to help you make the place the order.
Yes.
Okay? I don't know if they need a reference probe. So we do have the Acumac probe, that is AM1210. The length is a 20-inch. We have actually two kind of the regular one is the just a regular thermocouple type S with 2 bare wires. So if the customer uses this one, they have to make sure the readout they have for this reference probe does have the internal temperature composition. Okay, so because this is a thermocouple testing, so they have to make sure the readout they use for the 1210 probe do have the internal composition.
Sure.
Okay, they do have the external temperature composition like SBAF or the true point water device. They can order this one, the AM1210/20/CG. CG means the cold junction composition. So the probe, that will be like the picture below. Okay, so the bottom one, this one, is the probe itself, and we have a wire to another probe like this. So this probe should be put inside of SBAF or the 2-point water device. So this side, that will be the cold junction composition element. Okay, and then a wire right here to go to the readout. So in this way, the readout should not use the internal temperature composition. They should select the external and fix the external composition temperature to 0 degrees Celsius. Okay, so this is the Accumac probe. I would say not a lot of customers, they need a reference because normally they have their own probe, the reference probe, something like that. But just a recommendation.
Right.
Yeah, we do have a 9 calibration modes inside of the program. Base metal long and empty chamber, like this one. Base metal long and the cup insert, multiple insert, like noble metal with the long, base metal short, empty chamber, something like this. Short with the top insert, short with the multi-hole insert, noble metal with the short, something like that. Also, the last one is annealing. Annealing is something that only just a few customers needed. So
this relieves the tension, it relieves the pressures within the wire, yeah?
Well, sorry, what's that?
It relieves the pressure within the wire, annealing?
Oh, yes, that's right. So for this annealing, normally you can do is just to put a probe inside of the furnace and then set up the temperature. We do have a program for that, and then set up the temperature, maybe 1,000 degrees Celsius or 1,200 degrees Celsius, no matter what, and then like keep heating for 2 hours. It depends on the regulation, something like that. In China, we have like for the Type S, we have like 1,100 degrees Celsius for 2 hours, something like that. But maybe in New Zealand, we have different regulations, something like that. So this is annealing. Yeah, this is annealing. For the annealing, you don't need to use any insert. You just drop the probe inside of it and reach the high temperature and keep heating, and that's it. This is annealing. So when do the customers need to do the annealing? Normally, we'll say, actually, it depends on the using frequency of their probe. But normally, we do recommend to do the annealing once a year. And because annealing is pretty simple with this solution, so they just drop the probe and get high temperature, and that's it. So normally it's just once a year, stuff like that. One thing I want to say is that we do need to select the calibration mode in the manual because different modes have different algorithm to optimize the entire temperature. So, for example, for the short solution, we may concentrate the heating energy in the left side, okay, not in the middle side or the right side, something like that. So we do recommend to select the right mode when they do the testing. Okay. Yeah, I think that'll be it. So normally, the most important thing is this is just a heating source. So they need a readout. But to compare with our competitors, the good thing for this one is the color touch screen, pretty simple user interface, special long and short solution, multiple hole and cup design insert, and also the alumina kit for the normal metal. And of course, faster heating and faster cooling. So that would be
what is the heating time from ambient to 1200?
Let me see if I do have it right here or still on the data sheet. No, let me check the data sheet real quick. Yeah, so the heating time, that would be 40 minutes.
40 minutes?
From, Yeah, 40 minutes from room temperature to 1200. Cooling time, that would be 90 minutes from 1200 to 300 degrees Celsius.
Yep.
The temperature range, one thing is the temperature range of the furnace is from 300 to 1200. This is actually a range for the uniformity and the stability specification guarantee. So it doesn't mean the temperature of the furnace cannot go below the 300 degrees Celsius. You can still set up the temperature like 50 degrees Celsius, which means you can faster cooling the furnace to the room temperature, something like that. But all the specifications, like the uniformity and stability right here, is guaranteed only within the range of 300 to 1200 degrees Celsius.
Sure.
Okay. Yeah, the reason why we do that is just because the heating components has a limit like performance in high temperature. So if you look at our competitors, they still get the same thing, 300 to 1200. They don't get this specification below 300 degrees Celsius because the heating wire has a pretty unstable thing if the temperature is below 300. Yeah, something like that. This is all because the heating wire has a pretty high resistance. Something like, but below 300 degrees Celsius, the supply is not that stable. So that means we may have a pretty bad stability or the uniformity, something like that. But this is a pretty common to with other competitors. So we actually don't need to worry about that. Yeah. One more thing is the packing of the A50 is pretty huge one. I think over 75 kilo. Yeah, maybe. We have a wooden packing like that. Let me see if I still have it. I think we do have a video. Let me check. We do have a video for that one. Oh yeah. Here's a picture, actually. So this is the packing. Not sure if you can see this. Yeah, so as you can see, we have a wooden box like this. Okay, and with the bottom one, that would be it's a pallet, stuff like that. I'm not sure if the if the New Zealand government has some regulation for the wooden stuff, but I will check. Normally, it should be okay, something like this. So this is the packing of the A50 furnace. If you do offer the insert, no matter it's the metal insert or the alumina kit, you will have another box for the insert, stuff like that. So this is the packing. It's a pretty huge one, 70 or 75 kilo. Yeah. Sorry, I can't hear you. I don't know what's going on. I can't hear you. Nope. It's No. Um, yeah, no. Seems your microphone is offline. Strange. Um, no. Yeah. Probably your microphone is offline. Okay. Um, mm, no. What's going on? Uh, 哎，贾哥，我这个视频呢，我一会儿给你转过。哎，好的好的。啊yeah, here we go. No. What? Uh, what? Is this the internet problem? The speaker is okay. Let me check.